We will we'll start off the class kind of reviewing some things, and I've got a mixture of all the type of formulas that we've had to write names for. I notice on the assignments in general, going through them, that students don't. Some students are struggling with when to use Roman numerals, and also how to find the Roman numeral once you figure out it needs a Roman numeral. Okay, that's the most common mistake that's made on all the assignments that we've done to this point is when do we need to use a Roman numeral and when not, and then when we have to use one, how to find which Roman numeral it is or its charge. So the first thing I'm going to ask you is, we'll have these numbered 1 through, you guys don't have to write these down. Okay? Because we're just using them to kind of differentiate between the two different types of naming, and then also if we need to use Roman numerals or not. That's all we're doing. So, which numbers represent binary ionic compounds? Which numbers are binary ionic compounds up here? Okay, number 1, because there's 2 elements involved.
1 and 8.
And 8, and that's it. What do they all end in?
Element.
Wait, what?
Not
They all end in I-D-E.
Oh.
Okay, so they all end in I. The rest of the endings come off your polyatomic ion sheet. That's what makes those really easy to work with because, you know, chlorine, Cl is usually chlorine, but when it forms an ion, it's chloride, like number 1. And same with 8. It's usually iodine, but because it's picked up an electron, we need to differentiate between what iodine is, which is no charge, and iodide, which has a charge.
We'll get the sheet on the test, right?
Yep.
Okay.
Yep, you guys, just like your periodic table. Okay, second thing. Second thing is, if you notice, all the rest are polyatomic because there's 3 or more elements involved. So, the next thing that we need to do, we need to identify this first element to decide if we need a Roman numeral to write the name. So, when we look it up, we got to realize that middle section of the periodic table, if it's in there, is probably 90-something% of the time we have to use a Roman numeral for it. But you don't have to guess because you can look right above it and see if it has multiple numbers, you have to use it. So does number 1, do we have to use a Roman numeral? Yeah, because it can be a 2 or a 4. So, now, as you guys realize, when you guys know the names and know the symbols, it's much easier looking these up, right?
Yeah.
So that's why had you guys do that memorization, as in knowing how the symbol linked to the name and vice versa. Because, you know, it just becomes a little, if you're not familiar with it and where to look, sometimes you can look for a while and it's like, where is that, especially the ones we haven't used very much. So this is a -1, we got 2 of them, so that name would be, what, lead?
Chloride.
Nope, lead 2.
Oh, shoot.
Chloride. Right?
Yeah.
Don't write lead chloride, write lead 2. So next one, do we need a Roman numeral?
Whoa.
No.
Number 2, do we need a Roman numeral? No.
How do?
Yeah.
Oh, never mind.
Well, you can always tell because if it has just one number above it, which is group 1 and 2. If it's in those first 2 columns, no Roman numeral is required. Number 3, do we need it? Yeah, it can be a 1, 2. 1 or 2. So this is a -1, we got 2 of them, so that would be copper 2. Right? Okay. Number 4, do we need it?
No.
Nope. 5?
No.
Nope. 6?
Maybe. Yes.
Yes.
Yes. So this is a -3. We have 2 of them. There's 3 of these. What's the charge of cobalt going to be? 2. Cobalt 2. I'll have people write cobalt 3 because they're using this 3. And the 2 represents the charge, not how many you have. So we got to make sure that we're doing that correctly. 7, do we need it?
No.
How about 8?
Yeah.
Yep. So this is a -1. So copper is going to be a
Copper one.
+1. So it'll be copper 1 iodide. Okay, quick review. When to use Roman numerals, when to not to use them.
Oh.
Okay? Thoughts? Questions? Some of you go like, oh, I really messed up on your assignment. Just as we figure out what we're doing, just be accustomed to knowing that's a real problem on tests, is that's where people get lower grades because they don't use Roman numerals correctly. Okay? Now, the last type of namings on page 183, and these are molecular compounds. And molecular compounds is where we have two, in binary molecular, we're going to have two nonmetals hooked together. So, I'm going to give you page 183. Alright, so I'm going to give you two sides. I'm going to go, this side's going to be binary ionic, which we've already done. And this is going to be binary molecular. And I'm going to list out 4 elements or 4 compounds on each side that's represented. And then I want you to look at it and see if you can differentiate between the two sides. Okay? Just to kind of see what's going on. Okay? So, look at the two sides. They're both binary, but there's one distinct difference between the right side and the left side when you take a look at the overall equation.
The molecular side always has an oxygen.
Has what?
Oxygen.
Yes, it did. It did. Okay? So, let's do one without, without oxygen. Okay? Okay. That's good. It's a good observation. That's what I'm going for. But yes.
The molecular side, it's all nonmetals.
Yes. Does that make sense? The first one listed is a non-metal, as well as the second. That's what makes it molecular. You got 2 nonmetals or 2 or more. They'll say 2 or more nonmetals put together is molecular. Okay? And there's a lot of molecular compounds, but there's not very many that are binary molecular. Right? This side all has metals. We know how to name all these. That would be copper 2 iodide, sodium iodide, calcium fluoride, and iron 3 bromide. So we just went through that. Now, how do we differentiate between the two? Because these don't really have charges. I mean, they have what's called oxidation states, but they're not charges. And we could use Roman numerals, but preference is to use these things called prefixes. And the prefixes are, 1 is mono, 2 is di, 3 is what? Tri, 4 is tetra, 5 is penta, 6 hexa. You guys know what these come from, right? Okay. Geometry with, okay, 7 hepta, 8 octa, 9 nona, and 10 deca. Okay. So, what I'll do is I will name the first couple and then you kind of see what's going on. Mono is only used on the second, for the second element. Okay, so we only use mono if the second element, we've got one of them. Otherwise, we don't use mono for the first element if we got one of the first element. So that's how we deal with those. So this first one, for example, it's got 2 nitrogens, so that is what prefix? Dinitrogen. And then 4 is, okay, so I want to, it's a little thing, but you have to kind of be familiar. If you notice, I didn't put the A there, because when 2 vowels come together, we get rid of the A. So it's not tetraoxide, it's tetroxide. Tetroxide, not tetraoxide. So this A here will, with oxygen, specifically oxygen, because a lot of them are oxygen, we're going to take it off, and so that's the first one. The second one you're familiar with, that would be carbon. So we won't say monocarbon, but it's carbon. And then the second one is monoxide. And that's that poisonous gas that you can't smell, that sometimes you hear about people being exposed to and getting real sick, and it could be, if they're exposed to it for long enough, actually die from exposure to it. Because it is odorless, and there's some characteristics about it will attach to the hemoglobin instead of oxygen, and that's what causes you to get real sick or eventually. So when you're out in a snowstorm and they say, I remember this from a long time ago for safety, and you run off the road. Now with cell phones, you can get help pretty quick. We didn't have cell phones. Okay, so to get in contact with somebody when you run off the road wasn't really, you couldn't do it. Okay, what's that?
You just have to help somebody.
Yeah, right. And you were smart about it. So this is probably not something that you have to worry about, but just in case, if it's a snowstorm and you go in an embankment, there was a gal that they said ran off the road and they couldn't hardly find her here on the radio. She'd called up cell phone, but she was hidden down in a gulch kind of area, and it was hard to see. And if you want to run your car intermittently if you can, and stay warm if it's real cold outside, but you also want to make sure your exhaust is cleared. Because if it's covered up with snow, plugged up with snow, it backs up in your car. So you got to go around and clear that out, then go back in and get warm. Okay? So, do the next 3. Do 1, 2, and 3. Okay? With cell phones and that's not as big an issue anymore, but it could be. I mean, there could be a possibility. And we've heard of individuals, not very doing, and when you link it in with all the other ones, then it becomes a little bit more, you have to tell the difference between the different types of compounds. So, number 1 on here is nitrogen dioxide.
Isn't it peroxide?
O2. Yep, she's looking on a list of the polyatomic ions, okay? And it could be considered a peroxide.
So why is it
Okay.
being changed?
That's in only like a couple situations where, and I'm not going to have any of those. Okay? So and I would probably give you a right if you said nitrogen peroxide because it is O2 on there, and I probably would have to accept that. But it's going to be dioxide. Okay? P2O5 is diphosphorus pentoxide. Not penta, but pentoxide. And then number 3, it's not on that sheet. We're using the prefixes. Because those are polyatomic. These are not polyatomic. These up here are binary. They're 2 elements hooked together. Okay? And number 3 is carbon tetrachloride. Carbon tetrachloride. All right.
Will the first element in binary always be a metal?
Yes.
Okay, always be a metal.
Always. Okay.